Welcome back, children. Next topic is complex plane or ergon plane. So what is the meaning of that? We know that corresponding to each ordered pair x comma y, we get a point in this xy plane, isn't it? Conversely, every point in the xy plane that corresponds to an ordered pair x comma y. So in the same manner, the complex number, what do you mean by complex number? A number of the form a plus ib, where a is known as real part of the complex number, it is denoted as z, and b is known as imaginary part of the complex number. So this complex number we can represent as an ordered pair ab in this xy plane. So then that plane is known as complex plane, or another name is ergon plane. Okay. So complex plane or ergon plane means the plane having each of its points corresponding to the complex number of the form a plus ib. So such plane is known as complex plane or ergon plane. Now, so x-axis and y-axis, y, let z is equal to a plus ib. So this a plus ib corresponds to ordered pair a comma b. So I can represent a comma b here, a comma b, this is the origin. Okay. So this corresponds to the complex number a plus ib. So this plane is known as complex plane or ergon plane. Let this point be p. Then if I join OP, we know that this OP means the distance between O and P. Okay. So O means the origin 0, 0. So what is the distance between O and P? OP is equal to root of x2 minus x1 whole square plus y2 minus y1 whole square. That is a square plus b square. Okay. So this OP is root of a square plus b square, and that is same as modulus of z. What do you mean by modulus of a complex number? Mod z is defined as root of the real part square plus imaginary part square. So that is same as this OP. So the OP represent modulus of z. Okay. Now this x-axis, the complex number is of the form a plus I0. That is, all the points on the x-axis is of the form a plus I0. That is, imaginary part is 0, only real part. So this axis is known as real axis, and imaginary axis, that is y. The imaginary axis is y because all the points on this y-axis is of the form 0 plus ib. Only imaginary part there. Here look, a plus ib. How did I mark in this plane? A, that is, you have to check on x-axis, and b on y-axis. So the real part on x-axis and imaginary part on y-axis. So x-axis is known as real axis and the y-axis is known as imaginary axis. Now this a plus ib, that is in the first quadrant, a plus ib. So what about z bar? Z bar means conjugate of the complex number, that is equal to a minus ib. Where is this a minus ib? A minus ib is the ordered pair a comma minus b. So that is in which quadrant? First, second, third, fourth quadrant. Which quadrant? A comma minus b is in the fourth quadrant. So here a comma minus b. So these 2 points are mirror images with respect to the real axis. Okay. So every complex number we can represent as, every complex number of the form a plus ib we can represent as ordered pair a comma b in a plane. That plane is known as complex plane or ergon plane. Now the x-axis is known as real axis, y-axis is known as imaginary axis. Why this is known as real axis? all the points on the x-axis is of the form a plus I0 and all the points on y-axis is of the form 0 plus IB. So, it is imaginary axis. Then if P represent the complex number a plus IB, OP is the distance between O and P, that is equal to root of a square plus b square. So, that is same as modulus of the complex number. Then mirror image, if a plus IB is P, then a minus IB, that is the conjugate of Z. So, that we can represent in this plane, in this quadrant, that is fourth quadrant. So, it is the mirror image of this with respect to the real axis. Now, how to represent? Look this question. Represent the following complex numbers in complex plane. So, I have drawn one complex plane. As xy plane, the same manner. 6 complex numbers are here, we have to represent in this plane. So, 2 plus 4i, that corresponds to the ordered pair 2, 4. The second one, minus 2 plus 3i, we can represent as minus 2, 3. And the third one, 0 plus 1i is 0, 1. 2 plus 0i, that is 2, 0. Now, minus 5 minus 2i, ordered pair, minus 5 minus 2, and 1 minus 2i is 1, minus 2. So, represent these in this plane. 2, 4, 2 is in x-axis, 4 is in y-axis. So, 2, 4 we can represent here, that is A, I put A, okay. So, A, what is the point? 2, 4, or A represent the complex number 2 plus 4i. Now, the next number minus 2, 3, minus 2 x-axis, 3 is in y-axis. So, it is somewhere here, okay. So, that let be B, that point is minus 2, 3. So, it represents complex number minus 2 plus 3i. Then 0, 1, that is real part is 0, only imaginary part. So, 0 x-axis, 1 is in y-axis. So, this is the point C, 0, 1. Now, the next is 2, 0, that is only real part, no imaginary part. So, that is on x-axis, 2, 0, let the point be D. Now, minus 5 minus 2, that is in which quadrant? Third quadrant, minus 5 x-axis, minus 2 y-axis. So, minus 5 minus 2, let the point be E. Now, the last one, 1, minus 2, 1 x-axis minus 2 y-axis. In the fourth quadrant, 1, minus 2, at the point B, F. So, we can mark all the complex numbers in this xy plane. That plane is known as complex plane or Argand plane. When we represent complex numbers in this plane, then that plane is known as complex plane or Argand plane. Now, the next topic is quadratic equations. What is a quadratic equation? Quadratic equation means an equation of the form ax square plus bx plus c equal to 0, where a, b, c are real numbers, belongs to set R means set of real numbers, and a cannot be 0. So, that's a quadratic equation. The last year you have studied how to solve quadratic equation using quadratic formula. So, what is the quadratic formula? So, before that we have to find discriminant. Discriminant is equal to b square minus 4ac. So, the quadratic formula x is equal to minus b plus or minus root of b square minus 4ac by 2a. If b square minus 4ac is greater than or equal to 0, you will get two distinct real roots. If b square minus 4ac is equal to 0, two equal real roots, and if b square minus 4ac is less than 0, what we write? The roots are imaginary. Imaginary means complex roots you will get. So, here we have to discuss that how to write the roots of quadratic equation, imaginary roots. For example, if the quadratic equation x square plus 2 is equal to 0. Okay. So, x square is equal to minus 2, or x is equal to, you have to put plus or minus symbol, root of inside the root minus 2. So, how to write root of minus 2? Last class we have studied how to write root of minus 2 is same as minus 1 into 2. Okay. And root minus 1 is I. So, we can write plus or minus root 2 I. So, the roots are imaginary. If I is there, then that is known as imaginary number. So, roots are plus root 2I and minus root 2I. Then another example, x square plus x plus 1 is equal to 0. So, x is equal to, by quadratic formula, x is equal to minus b. A is 1, b is 1, c is 1. So, minus b plus or minus root of b square, that is 1 square minus 4 into a into c, 4ac by 2 into 1. So, that is equal to minus 1 plus or minus root of 1 minus 4. So, that is minus 3 by 2. And how to write root minus 3? Minus 1 plus or minus root 3I by 2. We can't simplify that since this second part is imaginary. So, just you have to keep as itself. Minus 1 plus root 3I by 2 is one root. The second root is minus 1 minus root 3I by 2. So, roots are imaginary. Now, the next one, solve x square plus 3 is equal to 0. So, x square is equal to minus 3, x is equal to plus or minus root of minus 3, that is same as root 3I. Okay. Here x is equal to minus b, that is minus 1 plus or minus root of b square minus 4 into minus 1 into minus 2 by 2 into minus 1. That is root of 1 minus 8 by minus 2, or minus 1 plus or minus root minus 7 by minus 2. Root minus 7 we can write as root 7 into I by minus 2. Okay. Now, the next, x square plus x plus 1 by root 2 is equal to 0. So, x is equal to minus b, that is minus 1 plus or minus root of b square minus 4 into a into c by 2 into 1. So, minus 1 plus or minus root of 1 minus 4 by root 2 by 2. Then how we simplify 4 by root 2? 4 by root 2, 4 is 2 into 2 by root 2. 2 and root 2 we can cancel. 2 and root 2 cancel and we can write 2 root 2. 4 by root 2 is same as 2 root 2. So, that is equal to minus 1 plus or minus 1 minus 2 root 2 by 2. So, here we didn't get I, but 1 and 2 root 2, which is greater? 2 root 2 is greater. Root 2 means 1.4 something. So, 2 into 1.4 is more than 1. So, this inside the root, that part is negative. Actually, it is negative. So, we can write as the greater number we can write first. So, minus you have to take outside. Minus of 2 root 2 minus 1 by 2. Okay. So, this minus means actually it is minus 1 itself. So, minus 1 plus or minus 2 root 2 minus 1 into root minus 1. So, that is I by 2. or I you can write here, no problem. Okay. Now the fourth one, x is equal to minus b. Minus b means minus 1 by root 2 plus or minus root of b square, that is 1 by 2 minus 4 into 1 into 1 by 2. So minus 1 by root 2 plus or minus 1 by 2 minus 4, or when we cross multiply that is same as 1 minus 8 by 2 or minus 1 plus or minus root of minus 7. Here root 2, here I can write root 2, then by 2. Now root minus 7, how we write root minus 7? Minus 1 by 2 plus or minus I root 7 by root 2, then again by 2 by 2. So it is minus 1 plus or minus I root 7 by 2 root 2. So that's the